Leetcode 127, Word Ladder. Change exactly one letter per move. Each word after the start must appear in word list. Return the length of the shortest sequence from begin word to end word, or 0 if no path exists. On the example, read along the arrows, hit, then hot, then dot, then dog, then cog. That is 5 words, matching output 5. The lines above are the inputs, begin word at, end word be, plus the word list. 2 letters so every vertex fits on screen. Each list word becomes a box. Connect 2 words with a line when they differ in exactly one position. The answer is the fewest words on a valid path from start to target. Here, start is at, target is B. Breadth first search walks the graph layer by layer. First the start word. Next, every one-step neighbor. The first time we dequeue the target, we have used the minimum number of words. Here that is 3, at, then BT, then B. Solution, breadth first search. Begin word may be missing from word list, it is still the start. We ask is this word allowed many times, checking a list would rescan every time, so we use a set for fast membership. Then BFS with a Q, distance, and scene, the graph on the right is the full toy picture. Put begin word at in scene first, then NQ at distance 1. In this pattern, scene is updated when a word enters the queue, not when it is dequeued, so the same word is never NQ'd twice. To expand a word, try each position and each letter. If the new string is in word set and not in scene, we NQ it with distance plus 1. For example, change the first letter of at from A to B, that yields BT, a valid neighbor. Dequeue at. It is not the target. NQ BT at distance 2 and add BT to scene the moment it joins the queue. NQ AE at distance 2 and add AE to scene the same way. Dequeue BT, not the end word. The queue front is now AE. NQ neighbor B at distance 3 from BT, and add B to scene as soon as it is NQ'd. Dequeue AE. The queue now starts with B. NQ TE at distance 3 from AE, and add TE to scene when it is NQ'd. Dequeue B. It matches end word BE, return distance 3. Shortest chain, at, BT, B. If the queue drains without dequeuing the end word, no transformation exists. Return 0. On larger inputs the same breadth first logic applies, we generate neighbors on the fly instead of drawing the whole graph. Let n be the size of word list and L the length of every word. Time is order n times L squared in the worst case. Breadth first search takes each word from the queue at most once, and from each word we try every position and every letter, doing order L work to build and check a neighbor. That is still shortest path in an unweighted graph because the first time we dequeue end word we have used the minimum number of words. Space is order n for the queue and the visited set, plus the set of list words. Pseudocode for word ladder. Function ladder length takes begin word, end word, and word list. Put all list words in a hash set for fast lookup. If end word is missing from that set, no valid ladder can end there. Return 0. Start scene with begin word only. The queue holds pairs of word and current chain length, starting at distance 1. While the queue still has states to expand. Pop the front pair as W and D. If W is the end word, we found a shortest ladder length. Return D. Otherwise try every index I in W. For each letter C from A to Z. Skip when C matches the existing letter at I. Build NW by substituting C at position I. If NW is a valid dictionary word and not yet seen, mark NW as seen. NQ/NW with distance d+1. If the queue empties without returning, return 0.